Hello guys, welcome to the Innovation Lab. In this video, we're going to be reviewing this 24 volt 100 ampere hour lithium ion phosphate battery system that is made by Sungold Power. Alright guys, as you guys know, the primary function of any battery system is essentially to store electrical energy such that when you need that energy, you can harness it, you can use it to drive different kinds of applications and different kinds of loads. So in a nutshell, we're just going to focus this video on looking at the core functions that this battery system has to offer. So to accomplish this, we're just going to push this battery to the limit. We're going to conduct all kinds of tests on the battery system, and in the end, if time permits, we plan to open up the battery system to take a look at the internal design of the battery. So overall, we're going to be conducting a whole lot of research projects, a whole lot of experiments using this system, and if you would like to see all of that, don't forget to subscribe to the Innovation Lab so you get notified as we are releasing these videos and conducting all this research. All right, my friends, let's get started. Alright guys, I know that a lot of us will be curious to see what's inside this battery system, and this is something I did at the end of all the testing that I had to conduct, but I wanted to show you guys the insides of the battery first before we go into all the tests. Opening the battery system was quite simple. All I had to do was to remove all the screw caps and then all the screws. So by removing those, we easily gained access into the battery system. Alright. So let's go ahead and take a closer look to see what's inside this battery system. And we're going to do this kind of in a high level. We're not going to tear down the battery because I'm still going to use it to conduct other tests, so I don't want to damage the battery system. I'm showing you guys all of this to satisfy our curiosity of what's inside the battery system. This is not something I recommend that you guys do on your battery system, because opening this up, you can make a mistake and short something inside this battery, and that could have a very bad outcome. So I highly recommend that you guys don't try this at home. One thing I like about this design is that the enclosure is IP grade 65, built with ABS plastic. Being IP grade 65 means that this enclosure is going to be water resistant, it's going to be dust resistant. So essentially, you can splash water on the battery system and it's not going to get inside the battery system to corrode anything or affect the lithium ion phosphate battery cells inside the battery. And as you guys can see here, there is a very nice rubbery silicone gasket here. And the design is such that when you close the lid on the battery system, it's going to give you that tight seal that's going to prevent water or moisture or dust or particles getting inside the battery enclosure. Alright guys, so what we can see here is quite simple, and I don't want to tear down the battery system too much because there's really no point in doing that. I can explain to you guys what we're looking at here. So kind of going from the left to the right. So what we see here is the positive power cable that goes direct to the battery positive, and the two black cables are kind of in parallel. So they are the switched negative that goes through the battery BMS, and you can see the battery negative actually comes in on this cable on this side, and it comes into the BMS. And so essentially the job of the BMS, battery management system, is to look at the state of health and state of charge of the lithium ion phosphate battery cells in the battery system, and if all the cells are within favorable conditions, the BMS switches power between the battery negative coming in here, as you guys can see here, to the output, which is here. So as long as everything is in favorable conditions, you have the switch between these two cables here and these two cables here gets closed, and if there is a situation that is unfavorable, the BMS will open up the switch here, thereby protecting the battery system. All right. So given what I know about BMSs, and also given the fact that this is a 24 volt lithium ion phosphate battery system, so this BMS should really be an 8S BMS, an 8S meaning 8 group of lithium ion phosphate cells connected in series. So the job of the BMS is to monitor each cell to tell the control system what's going on. And as you guys can see here, so this looks like the actual control board. The black, blue, and red wires, as you guys can see here, coming into this connector that now comes into the control board, report the individual voltage level of each group of cell in the 8S configuration. So the black here is the overall negative, And the 7 blue wires provide the individual voltage levels of each of the batteries in the 8S configuration. And lastly, the red wire reports the status of the very last cell, which is also tied to the overall positive of the battery system. All right. So besides the integrated circuits and all the other components that we can see on the control board, looking over to the switchboard side, we see a whole bunch of solid state switches here. I don't know exactly what these switches are. I didn't have the time to look them up, but this should be either MOSFETs or IGBTs or different kinds of solid state switches that are used for BMS design. And lastly, I see a small device here that looks like a thermistor or a temp sensor. So that would be my guess. I'm not 100% sure. And looking over here, I see another device here. It looks like another sensor to me, but to be honest, I don't know what it does. Overall, I would like to say that this is a very clean design. As you guys can see, it looks like a lot of design effort went into building this battery system, keeping it very nice and very simple, very organized. The only thing that caught my attention, to be honest, would be the internal power cables, as you guys can see here. So these look like either gauge 8 or gauge 10 cables. But one good thing they did was to connect them in parallel. So we have 2 of them in parallel. Honestly speaking, I was expecting to see a slightly bigger gauge, but then I could be wrong. But I'm sure that the Sungold Power engineering team would have characterized the ampacity of these cables to guarantee minimum dissipation at high loads. So other than that, what I would say is that, in my opinion, this design is quite impressive. This battery system comes with a very well written datasheet and product manual. And if you're thinking of getting this product, make sure you spend some time actually going over the product user manual, because there's a lot of information packed in there. So this battery is designed with grade A battery cells and is rated for 4,000 plus deep cycles, meaning that this battery can last up to 10 years or more and comes with a 5-year warranty. As expected, the battery comes with a very well designed battery management system, BMS. This is a 24 volt 100 ampere hour battery system, so that means the BMS can deliver up to 100 amps of current out of the battery system. This battery also has a built-in Bluetooth system that will allow you to connect to your phone to allow you to kind of look at the state of charge and many other useful information that you can get from that. Unfortunately, the Bluetooth connection or the Bluetooth interface, I'm not going to be able to test that in this video. So this battery system also comes with a self-heating function, which is also auto-activated. So that means that when the battery temperature drops below 33.8 degrees Fahrenheit or 1 degree Celsius, the self-heating circuit will kick in to maintain the battery temperature level. And this kind of stops when the battery temperature has risen above 42.8 degrees Fahrenheit or 6 degrees Celsius. This battery system comes in different flavors of 100 ampere hour or 200 ampere hour. And also you can get them at different voltage levels, 12 volts, 24 volts or 48 volts. Also, for a larger capacity, you can kind of connect multiple battery systems in parallel to build up a larger energy capacity that you need. Alright guys, so let's go over the core electrical specs of this battery system. So the version that we have is the 24 volt 100 ampere hour version, as you guys can see here. So the nominal voltage is 25.6 volts. And the nominal capacity is 100 ampere hours, as we have seen. The energy storage, which is essentially the nominal voltage multiplied by the nominal capacity, is coming in at 2.56 kilowatt hours, and that's a lot of energy storage capacity. The battery system has an efficiency of 99.5%. I think that this has something to do with the efficiency of the lithium iron phosphate battery cells, also the efficiency of the battery management system, BMS. So moving over to the charge and discharge characteristics, the charge window is between 21.6 volts and 29.2 volts, and the battery has a maximum continuous charge current of 100 amps, a peak 10-second discharge current of 200 amps plus or minus 3 amps, which means that this battery can, under such conditions, can push out about 200 amps to support whatever load you have at the moment. However, the recommended charge current for the battery system is right around 50 amps, and if you do the math, this is about 0.5 C. And as you guys know, C essentially represents the nominal capacity of the battery in ampere hours, which is the 100 ampere hours. So the recommended discharge current is also 0.5 C, which is 50 amps. And as we talked about earlier, the battery has a cycle that is greater than or equal to 4,000 cycles, which means you can fully charge the battery, discharge it about 4,000 times. And when you do the math, assuming daily use, this can easily translate to greater than 10 years of use. For the operating temperature ranges, so during the charge phase, the battery can operate between -4 degrees Fahrenheit to 113 degrees Fahrenheit, while during the discharge phase, the battery can operate between -4 degrees Fahrenheit to 131 degrees Fahrenheit. The battery system also comes with an LCD, which is kind of a visual output to the user, and I've really found that useful during my testing. I found that sufficient for all the information that I need, like a battery percentage, the charging voltage, battery voltage, all of that. I'm able to get all of that information from that LCD screen. So for this video, I didn't see the need to connect to the Bluetooth app, but I believe that a lot of good information was provided on the product manual to walk you guys through how you can connect to the Bluetooth app, which is quite simple and amazing. Alright guys, and lastly, given the capacity of this battery as a 24 volt 100 ampere hour battery system, I mean, if you compare this with like lead acid battery systems, this battery is super compact and lightweight, weighing only 45 pounds, and I think that's amazing. For the load test, given that what we have here is essentially a complete system, the battery, the power inverter, and the charger. So the plan is essentially to connect the battery system to the power inverter and then apply a load of close to 1,000 watts on the power inverter, and that way we're going to use that load to discharge the accumulated energy in the battery system. Given that we have already tested the power inverter and we are confident that the power inverter can drive up to 1,000 watts of load, so all we had to do was we configured a different kind of load, the set of light bulbs. So we have one 300 watt incandescent light bulb and a couple of 250 watt heat bulbs that we use for our chicken coop to keep our chicken warm during the winter season. And also I added some LED bulbs to the load configuration. Alright, so with everything now configured and good to go, all we had to do was to turn on the system and we turn on the timer, so we know exactly how long this battery system is going to be able to support close to 1,000 watts of load. But one thing we had to do, given that this is going to be a long duration load test, was to move the test load away from the test setup, because we don't want the radiated heat coming from the test load to kind of heat up either the battery system or the power inverter system. So one thing I would say is that even though the battery system is slowly discharging, meaning that the battery voltage is going to slightly drop and drop. So one thing I saw was that using the power inverter system actually helped to stabilize that load and compensate for that voltage drop by increasing the delivered current that is coming out of the battery system and going to the power inverter. So that helped us to maintain a steady state power draw of about 950 watts. As you guys can see here at this instant when we are making the measurement, you can see here a battery voltage of 25.80 volts and a load current going from the battery system to the power inverter system of 37.17 amps. So when you actually do the math at this instant, what you're supposed to see is right around 959 watts. So all I had to do was to essentially keep an eye on the system and periodically check on the system so I can capture the discharge response of the battery system at different time intervals. And in the very end, I was able to capture a time lapse of the system so I can show you guys what happened at the very end when the BMS of the battery system was able to turn off the load so as to protect the battery system from over discharging. Alright guys, for the battery charging process, given that what we have here is a complete system from Sungold Power and the pure sine wave inverter actually has a battery charging system built into it. So during our previous video, which was the inverter review video, we actually pre-configured the inverter system to also act as a battery charger whenever we plug in the input power to the inverter to our mains. Alright guys, so with the battery system connected and the charging system configured, all we had to do was to slowly adjust the charging current going from the power inverter system to the battery to about 30 amps. So our goal is to recharge this battery during the constant current phase with a charging current of 30 amps. So as many of us know, during the charging process for a lithium ion phosphate battery system, the battery is going to go through two different phases. The first phase that it's going to go through is a constant current charging phase, and after that it will go into the constant voltage charging phase. So during the process, we kind of carefully observed what happened during those phases. So as you guys can see here, during the constant current charging phase, as the name applies, what you guys will see here is the charging current remained at 30 amps while the battery voltage kind of slowly increased until we got to about 28.1 volts. So during the constant current charging phase is actually when we expect that the charging system will deliver the maximum amount of power to the battery system. So looking at our measurements here, we're seeing a battery voltage of 28.1 volts at a charging current of 30 amps. So if you do the math, so it's showing us that this charging system is able to deliver about 843 watts to the battery system. So essentially, the charging system being able to deliver about 843 watts of power going to the battery system, this tells us that this battery should be able to at least get to the constant voltage charging phase in about 3.5 to 4 hours. So during the constant voltage charging phase, the voltage of the battery system doesn't quite remain constant, but what you will see is that the battery voltage will begin to stabilize and you will see very small or very minute increases in the voltage level, while the charging current on the other hand begins to drop as it tends towards the float charge level. And when the battery system is fully charged, the float charge level is essentially going to be alternating between 0 amps to somewhere between tens of milliamps. Alright guys, one of the observations that I made during this process is that this battery system does not quite get into the constant voltage charging mode or phase until the battery gets to about 99%. My guess is that this could be some over design on the battery management system BMS, and if you ask me, I would say that is a good thing, because the implication is that you can essentially recharge this battery system in the constant current charging phase till you get to about 99%. So, and that is a good thing because you can charge the battery system faster, and at the same time, that over design means that you're not really pushing the battery to the maximum capacity. So you can get to what Sungold Power calls the 100% SOC, that's going to give you the maximum rated battery capacity without the battery spending too much time during the constant voltage phase. Alright guys, so overall, given all the testing that we have done with this battery system, I will say we have ran this battery through about 3 to 4 cycles, and that's full charge, full discharge, full charge, full discharge for about 3 or 4 times, and this battery performs really well. So in terms of verifying the 2.56 kilowatt hour rating of this battery system, I can comfortably say that we have validated that during the battery charging process. As you guys may have seen in the inverter test and review video, we kind of showed you guys an outdoor application of a system like this by using the battery system to drive the power inverter, and we use the inverter system to drive all kinds of saws that we use to do some wood cutting and also cutting up some pallets that we have in the backyard. However, in this video, I wanted to show you guys a different kind of application, a kind of a long duration, small load endurance test. And the idea that I have is to use the battery system to drive our pure sine wave inverter. And the overall plan is to use the power from the pure sine wave inverter to drive our portable deep freezer. So essentially, all I had to do was to go steal my wife's freezer to conduct this experiment for you guys. I hope I don't get in trouble. I hope you guys subscribe to this video, so when I get in trouble, at least I know it was worth it. So the test or experiment that we're going to conduct in this chapter of the video is to know if we can use 1 cycle of stored energy in the battery system, which kind of translates to approximately 2.56 kilowatt hours of energy stored in the battery system, to convert greater than 20 liters of water into ice. And if 1 cycle is not enough, what we plan to do is to halt the process, unplug the freezer, and recharge the system to know exactly how many battery cycles we need to achieve success in converting all this water into pure ice. Before we started the experiment, we had to run the numbers by doing some calculations considering the power rating of the freezer. The freezer is rated for an input current of 1.2 amps and an AC input voltage of 115 volts. So when you do the math, that gives us around 140 watts of power required to run this freezer. Now, considering the fact that this battery system has a rated capacity of about 2.56 kilowatt hours, so now dividing the rated capacity of the battery with the power requirement of the deep freezer gave us an estimated runtime of approximately 18 hours. Alright, so with everything connected and all the water has been placed inside the portable deep freezer, so all we had to do was to turn on the pure sine wave inverter and the system was running nice and smoothly. So at the end of the first battery cycle, we saw that this battery system was able to provide power to the entire system for about 19.5 hours, which was impressive. But full disclosure, as I was saying earlier, the plan was not to achieve our goal of turning all this water into ice using one battery cycle. We realized that we had to halt the process, trusting that the thermal insulation inside the deep freezer should be able to regulate the temperature for a few hours while we recharge the battery system. So essentially, after about a 3-hour recharge, we left the system to run for about another 10 hours, after which we were able to verify that all the water that we placed inside the deep freezer at this point had frozen into, I would say, 100% ice. So guys, overall, we were able to run this system for about 30 hours cumulatively. I would say that this experiment was successful. We were able to freeze all this water into ice. Although, as you guys have seen, I'm clearly not an expert in making ice, but that wasn't the premise of the experiment. As a matter of fact, this is an intro to a future solar off-grid experiment that I'm hoping to conduct in the near future, and if you guys would like to see that, make sure you subscribe to the Innovation Lab. Alright guys, the overall objective of this experiment wasn't just to make ice, it was to push this system to see how this battery system is going to perform over a long duration load test, even if it's a small load of 140 watts. So I wanted to see how this battery system will behave, and if you ask me, I'll say this entire system performed really well, and I'll call this a success. Alright guys, that's it for this video, and as you guys have seen, this battery system performed really well. I'll highly recommend it to you guys, especially for those of us who can afford it, to try it out for your DIY projects or for your solar projects. Overall, in my opinion, this battery system is well built and well designed. The only thing I saw that could be a design improvement is for Sungold Power to ensure that they include battery terminal covers to the design, just exactly as they had for the power inverter terminals. In my opinion, adding the battery protection covers will go a long way in protecting the end users from unanticipated or accidental shorting of the battery terminals. Alright guys, I hope you had some fun watching this video. I hope you learned something from the video, or maybe you got some entertainment out of it. And if you did, don't forget to subscribe to the Innovation Lab to get notified as we release all the future videos and all the future research and projects that we're going to be conducting using this battery system. Alright my friends, I'll see you guys in the next video.